Hello, guys. We have another question, another binary tree question. This is a binary search tree question. It's called all elements in two binary search trees, asked by Facebook, Amazon, and Google. Leetcode 1305. So basically, we've been given two different binary search trees, right? And they are asking us like if we can, return an output of integers where all the answers are sorted. So, right, we want or where all the answers are sorted, where the elements in the output are the nodes of both set trees. So we combine both set trees, right? So one way you could probably think about this is that if you didn't have an idea of where binary set tree is, if you're doing a brute force, what you do is that you just create a large list, and then you go through both binary set trees, right? So you go through this first one, you go through the second one, and then add every element to that list, and then you would sort it and then return it. And that will work 100%, but then you are not taking advantage of the innate properties of a binary search tree. And for the binary search tree, we know that the left root is less than the actual root, right? So the element to the left of a root is what less than that element, and the element to the right of that root is also greater than that element. So we can use that to our advantage by using the in order traversal, right? Where we first work on the left, work on the middle, and then work on the right, right? So if you do that, you see that first you have what 1, 2, 4. If you go through it in an in order traversal, right? So if you do that, you have everything sorted here, right? 1, 2, 4, and then come here, same thing. So left, right, so left, middle, and right, right. You see, you have everything sorted. You have a 0, 1, 3, right? Now, if you have these two lists which have been sorted, what you have to do is what to merge it, right? So the first one where you add everything to, right, the brute force when you add everything to your list, right, to be an n log n, right, or where n is all the nodes combined of both set trees, right? But we can have a more linear solution where we have m plus n, where the first the number of nodes in the first tree, let's say, is m, and then the number of nodes in the second tree is n, right? They combine, so we go through both of them. So it's m plus n, which is a way better solution than the total, which would have been what n log n. You know, yeah. So what we want to do is just implement the better solution, right? So first we need to get the nodes in order, right? And once we are done with that, we just write a merge function, and then that should be it. So say um first array list, I'll call it list one, right? It's a new array list, and then same thing with list two, right? So it's a new array list. Cool. And now we want to what have a function, and it's going to be called get nodes, and get nodes, and we pass the list that we want to be changed, right? So I'll call it get nodes, right? Root.2. So I'm passing it through root.2 and list.2. So basically, I'm saying when we're writing get nodes, right, I want them to add every element in the tree to what list one, right? For root one, and for root two, same thing. Do the same thing. Add it to our list, right? So once we are done, and then we'll have our merge function, right? So basically, we'll have our merge function. But before we have write our merge function, I just want to write what the get nodes function, right? So it's a void method get nodes, and it's going to take what a root and a list, right? So a list of integers, call a list, and then if the root is equal to null, right, then we are terminating. So we want to return else, right? We want to say, and actually it's get nodes, sorry. So get nodes, we want it to go on the left side first, right? Like we are doing with the binary search tree, where we go 1, 2, 4 for the first one in the example one, right? And then we work on the middle element. So for the middle element, you say list dot add what root dot val, right? We're adding the root val, and then we say get nodes what's root dot right with recursion, right. So now we have both list one and list two having what all the elements that we need from both trees. Now, how do we merge them? Notice that they are both sorted, right? So we will have two pointers. I want to call one I and I'll call the other j, right? So I will go through list 1 and j will go through what, list 2. So I'll just have a while function, right? So while I is less than what, list 1 dot size, right? And j is less than what, list 2 dot size, then I want to keep the values respectively, right? So I'll say var1 is equal to list 1 dot get my I, wherever I is, right? And then same thing for val2, right? So excuse me, val2 is what, list 2 dot get j. Okay, right. So after that, what do we are we interested in doing? Now we are keeping the values in val one and val two. Now we just want to compare both of them, right? So we say that if val one is less than what, val two, then we want to put val one in what, result array. And actually, I didn't even create one, so let me create one here, right? Because this is what we want to return, our result array. So it's integer of our results, it's a new array list. Okay, cool. Right, so saying that the result, come on, result dot add var1, right? And when we add var1, what we want to do is now increase the pointer on I, right? So that we go to the next element in list 1. Else, if it's equal, or var2 is less than var1, then what we want to do is what, say result dot add was var2, right? And then increase j. And so our loop will keep running and running till it terminates. And when it terminates for one of them, maybe it hits the end of list 1 first or the end of list 2 first, right? Then if there are elements that are still remaining, right, what we want to do is just to add them to our result. We know that it's already sorted, so the elements that are remaining, they are greater than anything that is already in our result, so we don't need to like do any merge from there on. So we'll check that if I is what, less than list 1 the size. Now, if it is, then I want to write a while loop and say that while I is what's less than list 1 the size. What we want to do is just do the same thing. So result dot add list 1 dot get I, and then we increase our I, right? So I plus plus. Basically, it's a nice while loop. And just to avoid confusion, I'm just going to say do pretty much the same thing for j, right? Which is what, ask the condition first, and then ask create our while loop, right? So we'll say results add list 2, let's get j, and then we increase j. Right, so once you're done merging both elements, you're adding them to the result, right? I think at this point we are done. So what we want to do is return our result. And as we previously discussed, the run times, right? This is going to be an of n operation, right? To get each node. So you see, we do it twice, right? But because it's linear basically, O of n operation, right? So you total to be O of n, right? Whatever n is. So let's say n is the number of nodes in root 2, and here's what the number of nodes in root 1 will be, maybe say m, right? But here's the combination where we go through both of them almost at the same time, right? So it's O of n plus 1. So passing the first 3 test cases, let me see, already like this. And here we pass. So 91% of other Java users beat. Hey, it looks good to me. I hope the concept was well explained, but basically we get the nodes using in order traversal and then we match them. I hope you guys have a good one.